In this final video in our series of lectures on pandas, we'll detail how to work with time series data. So here I'm using the read HTML method to read a table off of a website. It's going to take some time because it's reading over the internet. But we see that the result is we have simply the world population year to year from 1950 onward. So it goes from 1950 to 2049, which hasn't happened yet, but presumably it includes population estimates for future years. Now, it's very commonplace to work with time series data to represent, for instance, user engagement over time, sales over time, prices over time, measurements from sensors over time. There's a lot of data that we collect from moment to moment, and we're interested in how the signal evolves over time. If we set the index of this data frame to that year column, then we end up with a data frame with a date-time index. And this is going to let us resample our data points at different frequencies if we so please. So we might, for instance, be collecting stock data, stock prices. We might be collecting them every second. But depending on your line of work, you might not need them every second. You might just be interested in the daily price. In which case you would want to downsample the frequency with which you have your measurements from a day to just from 1 second to down to just once a day. So you're dramatically reducing the volume of your data from 24 times 3600 seconds a day down to just one data point for that entire range. We can downsample or upsample our data by using the resample method. And resample is essentially a group by, where we're going to group rows up based on the values of the date-time index itself. So we're doing essentially a group by on our date-time index. And we're, in this case, resampling to downsample to data once every 10 years. So all the rows for the 1950s will end up in one group, the 1960s will end up in another group, the 1970s will end up in a group, etc. And just like a group by, we don't stop at just constructing these resampling groups. We have to specify how we're going to aggregate the data to create our final result. So we can't just downsample by using the resample method. We have to say, when I downsample, how am I going to represent these 10 data points as a single data point? Because I'm taking the 10 years of data and bundling it down just into one data point for the entire decade. And in this case, I'm going to use a mean. I'm going to take the mean of all the data points in the 50s, the 60s, the 70s, and use those to represent each decade. So for the 50s, we end up with a mean population of 2.7 billion, the 60s 3.3 billion, etc. And this is different than if we look at the original. 1950 had a population of 2.5 billion. and 1954 had a population of 2.73 billion. Here we have taken a mean of all the years in the 1950s and gotten a mean population of 2.76 billion for that decade. So this is called downsampling because we're decreasing the frequency with which we sample the data. We're going from a high frequency of yearly to a low frequency of once per decade. We could also upsample, although it's much less common to do this because there's no way to actually collect data at a faster frequency. So instead of deciding how we're going to aggregate data from many points down to a smaller set of representative points, we have to decide how we're going to fill in all the missing data when we create rows for higher frequencies. So if instead of collecting the data every year, we wanted to represent it as quarterly data, we would have to say, okay, I have data for 1950. But if I create rows for first quarter 1950, second quarter 1950, third quarter 1950, fourth quarter 1950, how do I populate these new rows? How do I decide what data goes in them? And there's two main methods, backfilling and forward filling, where we just essentially say the data that will go in this new row is the same as the data that came before it or the data that comes after it. So with backfilling, we take, for instance, the data for 1950 and backfill it all through the quarters of 1950. Actually, this is the data from 1951, my mistake. So we take the data from 1951 and backfill it through all the quarters of 1950. The data from 1952 gets backfilled all through the quarters of 1951 until we hit the beginning of 1951, where we originally had data. Forward filling, we go in the opposite direction. So the quarters of 1950 get filled up with the data from 1950 until 1951 begins, and then we switch over to the original value for 1951, which has been forward filled through 1952. So all of these capabilities to work with date times in this way, using all this resampling, depends on Pandas timestamp class. I'm not going to spend a ton of time on the timestamp class. It's related to the Python datetime class from the datetime module. I don't know if this will work, but we can try it. Curious if I do from datetime import datetime and then ask, is a pandas timestamp an instance of datetime? It's not. So there's no direct inheritance here, I guess, but it is closely related. They behave very similarly, and all the kinds of operations you would expect to be able to do with a datetime object, you can also do with a pandas timestamp. Now, conveniently, a pandas timestamp will try to infer the format of a datetime string when creating a datetime object. So we don't necessarily have to specify the exact format of the datetime string in order to construct a pandas timestamp object. It's equally capable of understanding dates expressed in kind of as words, as sort of our traditional datetime format, or even as numbers of nanoseconds since January 1st, 1970. That is a point in time called epoch, corresponding with around the time Unix was released. We can take differences between times, as we might be able to expect. So 191 days passed between February 11, 2016 and August 3rd, 2015. We can also calculate offsets from a timestamp. And something that's really nice is Pandas comes with offsets for not only days or months, but also business days and business months. So we can ask, okay, not only what is 4 days before January 9th, but what is 4 business days before January 9th? So obviously January 5th is 4 days before January 9th, but 2 of those are Saturday and Sunday. So 4 business days before January 9th is January 3rd. We can also generate ranges of dates, sample that particular frequencies. So if we wanted all the business days from January 8th, 2017 to March 2nd, 2017, we could simply use the Pandas date range method for creating those. This is a very simple way to add timestamps to data you might already have loaded in if it's missing timestamps, but you happen to know how often it was collected and the starting and ending points of the data series. And as I said, since it's so similar to Python's datetime module, they are compatible with each other, and we can take differences between Pandas timestamps and datetime objects. I'm going to wrap up our discussion of Pandas by briefly highlighting that in the basic DS modules lectures, I introduced matplotlib. Many of matplotlib's basic functionalities are accessible through Pandas, which is very helpful for doing quick visualizations of data within data frames or series. So rather than, for instance, importing matplotlib and setting up a figure from there, we could take a series, apply a transformation, and use the hist method to quickly make a histogram of, for instance, the number of reviews each business has in our Yelp data. So this is really convenient. It lets us do kind of ad hoc visualizations on the fly to quickly explore data sets. There's also a plot keyword. For instance, if we wanted to plot year from year the annual growth rate in the world population, which from the mid-1960s has been steadily falling. This is maybe the end of the baby boom, at least in the United States. But of course, this is world population, so that's probably not particularly relevant. But there's all kinds of keywords we can pass to plot. Again, Pandas, if we search for plotting, the Pandas documentation has a whole user guide on visualization that includes many examples for making all sorts of plots directly from Pandas. Likewise, I didn't mention this or highlight this in the video on joins, but there is extensive documentation on joins with not only code examples, but visual diagrams. Okay, I don't know why. Oh, there we go. With visual diagrams of tables that we might want to join and what the resulting table would be if we performed the join in a variety of ways. So that wraps up the lectures on Pandas. I will, in the next series of lectures, be introducing some basic concepts from statistics that will be useful for the DW Mini project, as well as framing our thinking and understanding of data as we calculate some of these aggregations and transformations and help us make smart decisions about what we are doing.